The universe is vast, almost beyond comprehension. We look up at the night sky and see countless stars, distant galaxies and swirling nebulae, each a testament to the grandeur of the cosmos. But how vast is vast? How far does this cosmic ocean extend? Could the universe stretch on forever, an endless expanse of space and time with no boundaries or edges? The question of whether the universe is infinite has intrigued scientists, philosophers, and dreamers for centuries. It's a question that has sparked countless debates and theories. It's a question that pushes the boundaries of our understanding and forces us to confront the limits of our imagination. What does it mean for something to be infinite? Today, we'll journey together to the edge of knowledge and explore the mind-boggling concept of an infinite universe. We'll travel through space and time, seeking answers to this profound mystery. We'll delve into the scientific evidence, grapple with abstract concepts, and try to understand the nature of the cosmos, and confront the mysteries that still lie beyond our grasp. What secrets does the universe hold that we have yet to uncover? Our journey will take us from the fiery birth of the universe to the distant future, exploring the evolution of the cosmos, where the very fabric of space-time may be stretched to its breaking point. What happens when space-time itself is pushed to its limits? Fasten your seatbelts and prepare for liftoff as we embark on an exhilarating exploration of the cosmos and ponder one of the most profound questions ever asked. Is the universe truly infinite? Or is there an edge, a boundary we have yet to discover? Our quest begins with a fundamental observation: the universe is expanding. This expansion is a key piece of the puzzle. Like dots on the surface of an inflating balloon, galaxies are moving apart from each other. This movement suggests a dynamic, ever-changing universe. This expansion suggests that the universe was once much smaller and denser, originating from a single point in an event we call the Big Bang. From that moment, the universe has been growing, evolving, and expanding into the vast cosmos we observe today. The Big Bang theory is one of the most well-supported theories in modern cosmology. It provides a comprehensive explanation for the origin and evolution of the universe. It describes the universe starting from an extremely hot and dense state about 13.8 billion years ago and expanding ever since. This expansion has been ongoing, shaping the cosmos as we know it today. Evidence for this expansion comes from various sources, including the redshift of light from distant galaxies and the cosmic microwave background radiation, the faint afterglow of the Big Bang itself. These observations have been crucial in understanding the dynamics of our universe. Imagine a car speeding away from you, its horn blaring. The sound waves emitted by the horn stretch out as the car moves farther away. As the car moves farther away, the sound waves from the horn stretch out, causing the pitch to decrease. This phenomenon is known as the Doppler effect, and is similar to what happens with light waves in an expanding universe. Similarly, light waves from distant galaxies are stretched as they travel through an expanding universe, causing their light to shift towards the red end of the spectrum. This redshift is a key indicator of the universe's expansion. This redshift is a telltale sign of an expanding universe. It provides direct evidence that galaxies are moving away from us, and thus, the universe is growing larger over time. Furthermore, the cosmic microwave background radiation, a faint glow of microwave radiation that permeates all of space, provides a snapshot of the universe just 380,000 years after the Big Bang. This radiation is a relic from the early universe. This radiation exhibits tiny temperature fluctuations, corresponding to regions of slightly different densities in the early universe. These fluctuations are crucial for understanding the formation of cosmic structures. These fluctuations are the seeds of the large-scale structures, such as galaxies and galaxy clusters, that we observe today. They provide insight into the processes that led to the formation of the complex universe we see now. The Big Bang theory and the observed expansion of the universe provide a starting point for our exploration of infinity. They offer a framework for understanding the vastness and evolution of the cosmos. If the universe is continuously expanding, could it be infinite? This question leads us to ponder the nature of the cosmos and our place within it, opening up endless possibilities for discovery and understanding. To understand the concept of an infinite universe, we need to consider its shape. The shape of the universe is a fundamental aspect that influences its overall structure and behavior. Just as a flat sheet of paper can extend infinitely in 2 dimensions, a flat universe can extend infinitely in 3 dimensions. This means that if you were to travel in a straight line in any direction, you would never encounter a boundary or edge. A three-dimensional universe could potentially extend infinitely in all directions, creating an endless expanse of space. This concept is mind-boggling, but it's one of the possibilities that scientists consider when studying the cosmos. However, the universe could also have other shapes, like a sphere or a saddle. These shapes introduce different properties and behaviors to the universe. Imagine a team of ants living on a balloon. This analogy helps us visualize how beings within a curved space might perceive their surroundings. As the balloon inflates, the ants would observe that everything around them is moving away. This is similar to how we observe galaxies moving away from us in our universe. They might conclude that their universe, the surface of the balloon, is expanding. This is analogous to our understanding of the expanding universe, where galaxies are moving apart from each other. Similarly, we observe galaxies moving apart, leading us to the concept of an expanding universe. This observation supports the idea that our universe is not static, but dynamic and ever-changing. Now imagine the balloon has a certain curvature. This curvature can affect how the ants perceive distances and directions. If the ants walk in a straight line for a very long time, they might eventually return to their starting point. This would indicate that their universe, the balloon's surface, is finite and curved like a sphere. This would indicate that their universe, the balloon's surface, is finite and curved like a sphere. This concept of a finite yet unbounded universe is fascinating and has significant implications for cosmology. On the other hand, if the balloon's surface were flat, the ants could walk forever in a straight line without returning to their starting point, suggesting an infinite universe. This infinite flat universe would have no boundaries or edges. Similarly, the shape of our universe, whether it's flat, spherical, or saddle-shaped, has implications for its size and whether it's finite or infinite. Each shape presents a different model of the universe with unique properties and behaviors. A flat universe could extend infinitely, while a spherical universe would be finite, like the surface of our balloon. Understanding these shapes helps us grasp the vastness and complexity of the cosmos. However, there's a catch. We can only observe a limited portion of the universe called the observable universe. This is because light from the most distant regions hasn't had enough time to reach us since the Big Bang. The observable universe is like a bubble centered on us, with a radius of about 46.5 billion light-years. Imagine standing on a ship in the middle of the ocean. You can only see a certain distance around you, limited by the curvature of the Earth and your height above the water. Similarly, our view of the universe is limited by the speed of light and the age of the universe. The observable universe contains billions of galaxies, and within those galaxies, trillions upon trillions of stars. However, this vast expanse is just a tiny fraction of the entire universe, which could be infinitely larger. Just because we can't see beyond the observable universe doesn't mean there's nothing there. It's like saying there's nothing beyond the horizon just because we can't see it. The concept of the observable universe highlights the limitations of our perception and the possibility of a much grander, potentially infinite cosmos beyond our current reach. Imagine, if you will, that our universe is just one of many. The multiverse hypothesis suggests that there could be countless other universes, each with its own unique laws of physics and constants. It's a mind-bending concept, really, but one that has garnered significant interest in the scientific community. Some theories propose that these universes could be parallel to our own, existing in dimensions beyond our perception. Others suggest that new universes are constantly being created, each branching off from different points in time. While we may not have concrete evidence yet, the idea of a multiverse opens up endless possibilities for understanding the nature of reality. It's like, wow, just thinking about it can be quite overwhelming. But who knows? Maybe one day we'll uncover the secrets of these other worlds. For now, the multiverse hypothesis remains a fascinating and speculative frontier in the quest to understand our cosmos. As we delve deeper into the cosmos, we encounter phenomena that defy our understanding. The sheer scale and complexity of the universe challenge our perceptions and push the boundaries of science. It's both humbling and awe-inspiring, reminding us of how much we still have to learn. Olbers' paradox poses a fascinating question. If the universe is infinite and filled with stars, why is the night sky dark? This paradox has puzzled astronomers for centuries. The answer lies in the expansion of the universe, the finite age of stars, and the limits of our observable universe. It's a brilliant example of how simple questions can lead to profound insights. Despite our advancements, there are still significant gaps in our knowledge. Dark matter and dark energy, for instance, remain elusive. We know they exist, but their true nature is still a mystery. Our current models can't fully explain the behavior of black holes or the conditions of the early universe. These limitations remind us that science is an ever-evolving journey. Looking ahead, the future of cosmology is filled with promise and intrigue. New technologies and missions like the James Webb Space Telescope aim to uncover more about the universe's origins and its ultimate fate. Open questions, such as the nature of dark energy and the possibility of multiverses, continue to inspire and challenge scientists. The quest for knowledge is never-ending, and each discovery brings us one step closer to understanding the cosmos.